So the final talk of this BioTrek session will be by Silvia Pittolo with a talk entitled Illuminated Drugs.
Yeah. Can you hear me? Like that? Can you hear me? Okay, so good morning, everybody. I am Silvia Pittolo, PhD in biomedicine at the Institute for Bioengineering of Catalonia in the lab of Pau Gorostiza. And today I will try to explain to you what we do in our lab, and also I will try to explain to you some of the main important things I learned during my PhD, which are like general advices for people who is starting research, I hope. So the title of my talk is Illuminated Drugs, and how is this related to biomedicine? I'm not talking, of course, of some French intellectual taking drugs during the 18th century while writing the encyclopedia, of course. I'm literally referring to pharmaceutical compounds that the patient takes and they are inactive and need to be illuminated with light to become active into the body of the patient. And why do we want to do this? This is a good question, of course, and this is the first thing I learned, one of the most important things I learned during my PhD. You should always ask yourself what you are doing, if it is useful or not, because while what you are doing, it might not be practically useful, but still it could be useful as a proof of principle, like what I am showing to you today. But if it is really useless, there's no point doing it, even if your boss tells you so. You don't want to spend 4 years of your life on that, like on this. This is the useless box, and I saw it in the Museum of the Ideas in Barcelona 2 years ago, and it was, well, it was quite useless. So going back to the real, to my topic, why do we want to have drugs that you can activate with light? Well, because drugs can have side effects, and these side effects can be very severe. And side effects of drugs mainly depend on the drug being active in an undesired place and then at an undesired time in the body. So also light, it has a very high spatial temporal resolution. We can create light illumination patterns with high frequency and short duration, and also we can focus light in very tiny places with the latest technologies. So how can we combine these two things together? If we have a drug that can be activated with light, we can safely deliver it to the patient and without side effects because it is inactive, and then we just activate it where we want and when we want into the patient without side effects. So this is what we developed in our lab. This is called Switch 1. It is a molecule. That we can activate with light. We did it in collaboration with a medicinal chemistry group in Barcelona at the CSIC. And I don't want to get into the details of this molecule because there's not even enough time, but what I want to point out is that when we designed this molecule, we wanted it to be active on one receptor, and then we found out it to be active on another receptor. And this was not serendipity, it was just because one of our collaborators told us that the kind of molecule we designed could be active on both receptors, and we didn't know this, and this was really useful for us. So another advice is don't focus too much on what you're doing, because sometimes when we focus too much, we risk losing the big picture. So how do you want to do this? We don't want to, of course, to deliver light into the patient by implanting optical fibers, like in the case of what we do in animal labs. So it's good criticizing, but try to be constructive. And if we look for new technologies around the world, we can find these micro LEDs that have been developed recently that maybe could be implanted into a patient safely. So this is my last slide, and like personal advice, try to be generous, try to collaborate with people and talk with other researchers, and you will find out that talking with other people can help you more than 1,000 handbooks. Thank you, and thank you to all the people I work with.